Hello, welcome to week 5 of Health Science 475 Research Methods. This week we will cover different types of sampling techniques for quantitative studies and cover a little bit about power and effect size. So part 1 this week in our videos will be about different sampling techniques, and part 2 will cover effect size and sample size and power analysis. So now that you've completed homework 2, you need to start thinking about who is going to be actually in your sample and the idea of inclusion and exclusion criteria. And so our inclusion criteria are going to be the specific characteristics of the people or the things which we will learn are called your observation units. The specific characteristics of your observation units you will recruit into your study. For example, demographics, and then the actual health status in itself, whatever you're looking at. So for example, different types of demographics would be age, gender or sex, income, education, residence. So for example, only women in Orange County over the age of 50 years old. Right? So we're looking at location, Orange County, looking at gender, just women, we're looking at age over the 40 years old. And we can also look at health status, right? You might be wanting to just look at individuals who might have breast cancer and just women with breast cancer. In my research, I look at people who have fibromyalgia. So that might be an exclusion criteria for my research participants, is that you must have a diagnosis of fibromyalgia in order for you to be part of my study. So you need to think about in your study that you guys are doing for this semester, what are some inclusion criteria that you might need to have in order for your participants to be able to answer your questionnaires. Whereas the exclusion criteria, right, these are the specific characteristics of your observation units you do not want in your study. For example, like demographics as well, or even health status, right? So because you're looking at a testicular cancer study, of course you wouldn't want any women to be enrolled in your study. Hence, an exclusion criteria would be females. Or if you're looking at metastatic breast cancer, although men can get breast cancer, we might want to just look at just women with metastatic breast cancer, so you're going to then exclude men with metastatic breast cancer because you're only looking at women with metastatic breast cancer. Right? So your inclusion criteria, that your participants must meet these criteria. And then your exclusion criteria, your participants cannot meet any of these criteria. And so when you think about inclusion criteria and exclusion criteria, do they need to meet some or all of these? Well, when it comes to inclusion criteria, your participants need to meet every single one of the criterion that you list. Same thing with your exclusion criteria. If any of your participants meet any of your exclusion criteria, they cannot be enrolled in your study. So when it comes to your eligibility criteria, which is collectively what we call our inclusion-exclusion criteria, our eligibility criteria, your participants must meet every single one of the eligibility criteria that you have outlined. They all must meet yes for the inclusion. They all must meet no for the exclusion. So a little bit more terminology. So when you think about collecting or putting together your sample, we start with a census, right? And so a census is essentially all the people and all the things that meet your inclusion criteria, right? The data collection from all the people who meet your inclusion criteria. This would be your census. So think about the US Census. Every single person that's living in the US, we account for, or we try to count for. But then we have a sampling unit, the elements considered for selection as part of a sample. So these can be an individual, this can be an agency or an organization, it can be a geographic area, it could be an article that you might want to pull. Right? So a researcher, for example, might want to sample villages in Uganda, either households in Ugandan villages, maybe physicians in California, family planning clinics in Orange County, right? Different articles on Zika virus in the newspapers that people have read about. Right? So these are going to be the sampling units that we consider to be part of our sample. But then we actually start collecting data from the sample itself, which would be data collection from just some of the people or some of the things that you have identified within your sampling unit. right? So the sample is, we don't collect information from every single person within your sampling unit. We just collect information from some of them. And so our observation unit, which I mentioned in previous slides, are the elements themselves. Is it a person? Is it a thing? Is it an agency? Is it an article that we actually get the information or the data from? Within our research in health science, most of the time our observation unit is an individual. Who do we actually get data from? Who answered the questions? Who performed a series of tasks? And so we'll see later on in these slides in part one examples of how we put together these different terminology. But if we build on this in your textbook, there's also a few other terms that tie into the idea of sampling framework. So we have the universe. These would be all participants that meet your eligibility criteria, but in an unspecified time or a place. So for example, all Americans over the age of 50. If I'm looking at older adults who have fibromyalgia and those who don't, I'm looking at every single American over the age of 50. But then our population, right, those would be the individuals within your universe that are specified within a specific time or a place. So thinking about my research, right, looking at people with or without fibromyalgia, older adults, now we're thinking about all Americans who are 50 years and older, physically located in California on any given date. Let's say November 8th, 2016, one of my data collection dates. The study population would be those within the population that are accessible to me. So those who maybe are in Southern California, right? So those who are physically accessible to me within a specified time and place, Orange County on November 8th, 2016. And so from that study population that I have access to, I then pick a sample of those individuals. Right? Not every single person that is in Orange County, that is an older adult with or without fibromyalgia on November 8th, 2016, did I have access to. So I just picked some of those folks. And now some of those people from my study population now make up my sample. Right, so we have, again, this whole idea of these last few slides are the idea of our sampling framework. So if we think about who do you want to generalize to, right? This is your theoretical population, every single person that would fit your eligibility criteria, your universe. But what population can you actually get access to? This is your study population. Who do you physically have access to, either physically person to person or physically maybe even via the internet or via a phone call? But then how do you actually get access to them? This is your sampling frame. Right? And this is the important thing. How are you actually going to get access to these folks? If it's a phone number, do you have their phone number? If it's a group of students, which is that is your case in your research, right? How are you going to get access to these individual students? Whether it's an email, whether it's a Facebook page, right? How do you get access to them? And then eventually, who is in your study, right? The folks that you actually get information or data from, this is who we call the sample. So if we take a look visually, right, our big circle up here, our population of interest, right? We randomly select individuals from a population, which then make up our sample. And hopefully, our goal is to be able to generalize the findings from a sample back to the population of interest. And this is all hoping that our sample looks like our population of interest, right? They are representative of each other. And as long as we randomly select appropriately, and we'll talk about different techniques about that today, is as long as we can randomly select our sample from the population, then hopefully we can generalize those findings back to that population. So let's apply your project to this scenario, right? Looking at the population of interest, all Cal State Fullerton Health and Human Development undergraduate students over the age of 18 years and older. And you might even take out health science or HHD. But in this example, let's just look at all about 1,500 or so undergraduate students over the age of 18 who are health and human development majors. So actually, it's larger than 1,700. Right, you have nursing, you have child adolescent studies, health science, kinesiology, so a lot. So considering all Cal State Fullerton health and human development undergraduate students, we randomly select them. Let's say we're going to use simple random sampling, which we'll learn about in just a moment. And we have a sample of 500 health and human development undergraduate students over the age of 18. We hope that those 500 HHD undergrads look like you, that they are representative of you. And if they are, we can then generalize the results from our study, which collected data on 500 students, and hopefully generalize that back to the 5,000 plus HHD undergraduate students who were over the age of 18. However, this isn't always the case. Data are not necessarily exactly the same. We must assume that there is some error involved in how we sample and how we get the individuals, our observation units, from the population. Hence, we call this sampling error, also known as standard error when we talk about statistics. So sampling error, or the standard error, by definition, is the difference between the sampling estimate and the actual study population value. So if you recall, in class, I gave you the mnemonic of P and P, S and S. Your statistic goes along with your sample. The parameter describes your population. Statistics describe your sample. Parameters describe your population. And so, the difference between your statistic and your parameter is your sampling error. So if you tie this in back into stats and using some notations here, right? The sample mean, X bar, and your standard deviation, right? These are about your sample. Whereas when we're using Greek terms like mu, right? This is describing your population mean and your population standard deviation. And so the differences between your sample mean and your population mean would be the example of your sampling error. We can quantify that. So for example, if we just look at health and human development seniors, we have about 3,000 or so. And so these 3,000 Cal State Fullerton health and human development seniors, the population, their average population age was 20.5 years old. We randomly select students using simple random sampling, and we end up getting 100 HHD seniors, where their sample statistic is 20.9 years old. So our population parameter, looking at 3,000 health and human development seniors, the population parameter was 20.5 years old, whereas our sample statistic was 20.9 years old. What would be the sampling error? Simply plus or minus 0.4 or 0.4 would be the answer, right? So essentially the difference between the 20.9 and the 20.5, which is 0.4, would simply be your sampling error or your standard error. But what causes sampling error? What causes this difference in our sample statistic and our population parameter? Well, one is the sample is drawn from a non-random manner. And what we call this is selection bias. Did every single person have an equal chance of being selected to be part of your sample or not? Right? People selected to be in your study might be quite different from those who were not selected. Right? So if you didn't randomly sample, but you may have purposely sampled, right, then your sample may not look like your entire population. However, certain groups, like different racial or ethnic groups, might be under or overrepresented in a study sample compared to the population they actually comprise of in the population. For example, thinking about Cal State Fullerton, we are a Hispanic serving institution. So a large component or a large section of our population, of our student population, are Hispanic. What about maybe Hindu students? Right? A very small percentage of our students might identify as Hindu. Well, if that's the case, we want to make sure that we capture every single person that's representative of the institution, then we might need to ensure that we pick people from our sample, or we might not capture them, right? Out of almost 40,000 students, only a handful of these 40,000 students might identify as Hindu. So the likelihood of us capturing those folks in our sample are very, very low. So in that case, we wouldn't really say that our sample might look representative of the population. So we might need to do some purposive sampling in that case, and we'll talk about that later on. Also, the sample in itself might just be too dang small. Right? If we have 40,000 students at Cal State Fullerton, and you only sampled 10 students, what do you think that those 10 students are going to look and think like the 40,000 other students? Right? Do you think they're going to be very representative of them? They might look very different, right, in terms of their demographics, in terms of their line of thinking, in terms of their alcohol use, in terms of their sexual behavior, in terms of their health status, right? So because our sample might be too small, it may not be truly representative of the population. So then what do we do? How can we reduce sampling error so that our sample looks as close to our population so that we can generalize our findings from our sample to the population? Well, one strategy is we can use probability sampling to select participants. Right. Random selection is the method that reduces sampling error the most. So we want to incorporate probability sampling and random sampling when we design our studies in terms of the methodology to collect our sample. We can also draw a sample that is large enough to represent the sample population. Right? We mentioned that a sample could be too small. So then we need to make sure that we recruit enough people into our sample so that hopefully we can represent the population. In addition to that, we can actually see and achieve statistically significant results. And this speaks a little bit to part 2 of week 5, where we talk about power analysis.